Hello. The purpose of this video is to discuss the nomenclature of ionic compounds containing polyatomic ions. If you have not already viewed the video related to nomenclature of binary ionic compounds, it is strongly encouraged that you view it prior to viewing this video. Polyatomic ions are ions that are made up of more than one type of atom. In front of you, you see a list of all of the polyatomic ions you are expected to know for this course. You need to know not only the formula of the ion, but also its name. When looking at the formula, don't forget to take note of the ion's charge. To help you remember these ions, they are sorted by common central atom, meaning the atom found in the center of the ion. And there are a couple of tricks to the trade. Find on your screen the polyatomic ions with the central atom of nitrogen. Focus specifically your attention on the two polyatomic ions named nitrate and nitrite. Study the formulas of those two ions. You will notice that the nitrate ion and the nitrite ion have the same charge, 1-. However, you will notice that they have different numbers of oxygens. The nitrate ion having more oxygens than the nitrite ion. In this case, nitrate has 3 oxygens, nitrite has 2. Polyatomic ions that contain oxygen and end in ATE always have 1 more oxygen than a polyatomic ion whose name ends in ITE. If you look through the table, you will notice another example when you get to sulfur. Here you see sulfate, SO4 2-, and sulfite, SO3 2-. Again, noticing the ion that ends in ATE has more oxygens than the ion that ends in ITE. The ATE and ITE ending of the polyatomic ion's name does not tell you how many oxygens the ion contains. It simply tells you which has more, the one ending in ATE. Locate the ions that have a central atom of chlorine. You will notice that there are 4 of them. Chlorate is ClO3 1-, which based on the conversation we just had means chlorite is ClO2 1-. What do we do with the other 2 ions that also have differing numbers of oxygens? We add a simple prefix. In the case of ClO4 1-, a compound with 1 more oxygen than chlorate, we add the prefix per. So ClO4 1- is perchlorate. In the case of ClO 1-, which has 1 less oxygen than chlorite, which is ClO2 1-, we add the prefix hypo. So ClO 1- is hypochlorite. If you study the chart closely, you will see other interesting patterns that may help you remember the names and formulas of polyatomic ions. Ultimately, however, this is an exercise in memorization that is essential moving forward in chemistry. I strongly recommend making flashcards with the name of the polyatomic ion on one side and its formula on the other to help you practice names and formulas of these polyatomic ions. Let's talk about writing formulas of ionic compounds that contain polyatomic ions. The rules for writing formulas of ionic compounds do not change when the compound contains a polyatomic ion. In other words, we're going to apply the same rules that we used when writing formulas of binary ionic compounds. The key difference here is that we treat all of the elements in a polyatomic ion as a group when writing the formula. If we need more than one of a particular polyatomic ion, it is necessary to place the entire group of elements that make up that polyatomic ion in parentheses, followed by the appropriate subscript. This is probably best illustrated by an example. Suppose we want to combine magnesium ions, Mg2+, with nitrate ions, NO3, 1-. In order for the total charge to equal 0, we will need 2 nitrate ions. So the appropriate formula is Mg parentheses NO3 parentheses 2. Let's look at a couple of examples to be sure that you're on the right track. It's recommended that you read the following problem, pause the video, select an appropriate answer, and then resume watching the video for an explanation of the correct response. In this case, the question is, which of the following is the formula of the ionic compound formed when copper 1 ions, Cu1+, combine with sulfate ions, SO4 2-. In this case, the correct answer is C. The correct formula is Cu subscript 2 SO4. This is the correct formula because 2 times 1 plus gives you 2 plus, and 1 times 2 minus, the charge on the sulfate ion, gives you 2 minus. 2 plus plus 2 minus gives you a total charge of 0. You might notice that the only difference between the correct response, C, and an incorrect response, D, is that in the incorrect response, there has been parentheses placed around the copper. Monoatomic ions do not utilize parentheses. If you place parentheses around monoatomic ions, that formula is incorrect. This is why C is the correct answer and D is incorrect. Let's talk for a second about naming ionic compounds that contain polyatomic ions. There are several scenarios that can arise. First of all, it's worth noting that the rules for naming both positive and negative monoatomic ions, which we talked about when we talked about nomenclature of binary ionic compounds, remain the same. So, for example, if the positive ion that appears in your compound is Ba2+, it is the barium ion. Second, if the compound contains NH4+, the only positive polyatomic ion, then the name begins with ammonium, which is the name for NH4+, followed by the name of the negative ion. NH4Cl is ammonium chloride. Third, if the compound contains a negative polyatomic ion, which are quite common, the negative ion name is replaced with the name of the polyatomic ion. For example, NaNO3 is sodium nitrate because NO3 1- is the nitrate polyatomic ion. Finally, If the compound contains only polyatomic ions, then you use the name of the polyatomic ions, positive ion followed by negative ion, to construct the name of the compound. In these cases, the positive ion will always be NH41 plus ammonium, followed by some other negative polyatomic ion. In the example shown here, the negative polyatomic ion C2H3O2 is the acetate ion, so the name of the compound NH4C2H3O2 is ammonium acetate. It's worth pointing out that you must not forget about Roman numerals if the compound contains a metal with a variable charge. Let's look at a few examples. In this check for understanding question, we are asking which of the following is the correct name for CaOH2. Ca parentheses OH parentheses 2. Pause the video now, select your answer, and then hit play to see if you are correct. The correct answer in this case is B, calcium hydroxide. The positive ion is Ca2+, the negative ion is OH1-. Ca2+ is the calcium ion, OH1- is the hydroxide ion. The appropriate name for the compound is calcium hydroxide. Let's look at another example. Which of the following is the correct name for ZnSO4? Again, pause the video, decide on your answer, and then hit play to hear the explanation. The correct answer in this case is D, zinc sulfate. You might be asking, why is the correct answer not B, zinc 2 sulfate? The answer is that zinc, you might recall, is one of the transition metals that only forms a singular type of ion, in this case a 2+ ion. Therefore, it does not require a Roman numeral. However, if you were to encounter a similar question to this on an exam or quiz and placed a Roman numeral, I would not deduct points. The only time you should not include that Roman numeral is if it is clear that the metals are not transition metals. In other words, they definitely come from a main group area on the periodic table. Naming compounds with polyatomic ions and writing their formulas requires that you understand the names and formulas of all the polyatomic ions discussed at the beginning of this video. Be sure you practice those diligently. Many other examples and much more practice can be found in your textbook and materials distributed in